Hi, today after talking about multi-step equations, we also looked at some special situations where an equation doesn't have a solution or an equation is actually an identity and it has infinite solutions. And so I've got a couple examples here to give you. And then we'll talk a little bit about how we can spot these before we get all the way to an end of a problem. So I'm just going to go off the assumption like I don't know what no solution means. How would I even recognize this? So I'm just going to try to solve this problem and then we'll see where the problem is in that. So I'm going to distribute. So I'm still following those rules for multi-step. So I end up with negative 8x minus 4 is equal to negative 8x minus 2. All right, so then I would want to get my variables on the same side, and so I would add 8x, and I would add 8x to the other side, but what happens here, the 8x is gone on the right, but the 8x is also gone on the left, right? It cancels out on both sides. Negative 8x plus 8x does not make x. It's 0, right? They're gone. And so negative 4 is equal to negative 2. Not in this world, right? So what's left is not a true statement. And what that tells me, if the variables all cancel out, so it's not just gone on one side, the variables are completely gone. If the variables all cancel out, and what remains is false. In other words, negative 2 and negative 4 are not equal. So what remains here is false. They are not equal. That means there's no solution. There is no possible number that could work as a solution to this equation. And we can really kind of start to spot that sooner in the process if I see that the coefficient of the variable on each side is the same, negative 8x, right? But the constants are different, then that means there's going to be no solution. So we can't really pinpoint that until it's simplified. So in this next one, I have no reason to initially think that there's anything special about this. I think I should be able to solve it and get x equals some number. However, as we get started solving and we simplify by multiplying by 3, we're distributing, and then on the other side I'm just bringing this down. And then I would combine my like terms, and then I combine those like terms and I get negative 5, and I still have my minus 9x. And guess what? The other side, it looks exactly the same. So if that's exactly the same on both sides, I could choose any number that I want. I could choose 0, I could choose 5, I could choose 17, doesn't matter. 3,277,000, doesn't matter. It would be true no matter what. And if I didn't recognize that, oh, that's exactly the same, and once again, if I tried to keep going and I add 9x to both sides to get rid of these 9x's, but then it also gets rid of these 9x's, whoops, then what would be left is actually a true statement. Negative 5 does equal negative 5. So this is infinite solutions. There are infinite solutions. Or you may have learned before, or you might sometimes, as a math teacher, I might say that the answer is all real numbers, because I could choose any real number that I want and it would work. So notice in both cases the variables all canceled out if I keep working. But with no solution, what's left is a false statement. What's left in the other situation with infinite solutions is actually a true statement. And we could have, prior to adding 9x on both sides, if I see that both sides are exactly the same after I simplify, then I know it's infinite solutions. So we'll take a look at a couple more examples like that. So here in number 1, we've got a little more work to do. We've got to simplify first. You can't tell just from the get-go. We've got to do some simplifying. So if there's parentheses or like terms, we need to handle that first. So I distribute it. Now I'm going to put my like terms together. So 6x and negative 3x makes 3x. So I have 3x plus 6 is equal to 6 plus 3x. Well, those two things are exactly the same. The order is different, but they are equivalent to each other. So right there, as soon as I see that the left side and the right side simplify to be the same thing, I can just go ahead and say that there are infinite solutions. I do not need to keep going. All right? So if I was doing a problem here like number 2, and I distribute, and I distribute on the other side also, being careful with that negative. When I get to this point and I see that the number of x's is different, okay? So if the coefficients of the x is different, right? It's not the same number of x's on both sides. That means I need to keep going. I can solve it. Keep going. It can be solved. It has an answer. It has one solution. And then I just treat it like the problems that were just on your other assignment. So I'm going to take away 14x. Because now that I have different number of x's, I can get them on the same side, and they don't all just cancel out because the numbers weren't the same on both sides. Then I can add to get rid of that subtraction. Of course, always being careful when I think about adding, but that's a negative 28, not just regular 28. So that makes 8 as opposed to 64. And then divide by negative 2. So negative 2, sorry. So x is equal to negative 4. So on your assignment for that says infinite solution, no solution, which is on page 25 in your packet, 5 out of 10 of those problems will be one of the special situations. But 5 of them are just other problems that you can solve. So if I start, say, problem number 3 and simplify, so distribute on both sides. As soon as I distribute on both sides and I see that the number of x's are different, I know this is going to have an answer. I don't know off the top of my head what it is. Well, I actually do because I already worked it, but you would not. But you know that you can solve it. So you do have to keep going in that situation. If you keep going, this one you should get x equals 0. 0 is a real number. 0 is not a special case. In number 4, if I keep going, I'm going to distribute and then combine those like terms. And then we should stop and pause, and we could notice that both sides have the same number of x's. That means it's going to be a special case. The other numbers are not the same, so that means it's no solution. So again, that should help you on your homework that's on page 25.